Hey everyone. It's all right. Are you guys having a good day? Good. All right, it's a beautiful day. All right, let's get started. So, hello, my name is Tam. I'm the co-founder and the CEO of Test and Prod. Test and Prod is one of the core development team of the Optimism Collective. So, among the core development works that we do, we build and maintain op-erigon, which is an alternative execution client to the OP stack efficiency frontier. So today we're going to sync OP Aragon to the OP Girly. Let's go. Thank you. Guess it's not working. It is working. All right, overview. I brought three topics. The first topic is how does Optimism node work? In this topic, we're going to talk about the high level of the Optimism node and how does it actually sync the L2. And second topic is what is op-erigon? In this topic, we're going to talk about what is op-erigon, why op-erigon, and is there any other client implementations in the OP stack and why it matters. And then last, we're going to sync OP Girly with op-erigon and OP node. The first topic, how does Optimism node work? Basically, Optimism node is a Ethereum node plus a minimal difference. So basically, we inherited Ethereum's codes and the structure so that we can keep track to the Ethereum's like updates quite easily and to achieve the Ethereum equivalence at the end of the day. So we, like Ethereum, we have three components: consensus client, engine API, and the execution client. So the first component is the consensus client. It's a software that helps the network to agree on the chain data, and it passes a lot of like consensus information to the execution client. And the second component is a execution client. It's a software that executes all those transactions, stores the network states, and it gives out the states information to the users when the user requires the data. And the engine API, you can consider this as a bridge between consensus client and the execution client because it's a protocol that consensus client passes the agreed consensus into the execution client. Let's go. All right, so how does it actually sync? We're going to talk about the safest way to sync the chain, which is deriving the L2 chain from the layer 1. So first, the first step is consensus client receives the L2's list of the transactions and the block hashes from the Ethereum. And consensus client passes those transactions to the execution client with the engine API. But in this engine API, we have a slight modification, which is containing the list of the transactions on the engine API. Normally, we don't do it on Ethereum because rather than that, Ethereum, we allow execution client to find the transactions and the block data by itself with the peer-to-peer network. We did this modification because because we didn't want to execution client to query this layer 1 and we don't want it to make those hassles. And third, execution client executes transactions that consensus client passed. Boop. All right. And if the consensus checks if the execution layer's execution client's block hash matches to the hash that consensus client knows, then we sync the chain. We sync the not chain but a block. And if we iterate from 1 to 4 a lot of times, then we have the L2 chain. Cool. Please throw any question if you have anything in your mind. So what is op-erigon? It's an alternative execution client to the OP stack. It's built with Erigon client. As you could see in this little picture, Test and Prod has forked the Erigon client to make it compatible with the OP stack. So why did we fork? It's because Erigon is such a nice client. It has a lot of advantages. The first advantage is it supports the very efficient archive node size. OP-Geth for the OP Mainnet, it requires like 2.4 terabytes, but op-erigon, it requires only 0.7 terabytes, which is about like 30%. And it allows your faster sync for the archive nodes. Also, it supports much more API support. For example, you can use this amazing blog explorer or scan. Shout out to William there. Yeah, all right, let's go. And why do we even need an alternative client? Because, well, we have two reasons. The first reason is it provides more rich choices of software because each software has a always pros and cons. For example, Geth is very not very but like it's quite expensive, but it's very stable. It never fails. But Aragon is very efficient in terms of like time and space, but it's a bit experimental. And also, this is more important reason. Having diverse clients makes the network much more secure because when one client has a bug, other software clients can actually save the network. It happens on the Ethereum mainnet. There was a finality issue on like 6 months ago or something. There was some bugs in some client implementations, but one or two implementations was sober enough to keep the chain chugging, so that chain was able to proceed it without the finality. You might want to see this amazing postmortem that Off-Chain Labs wrote. You can see the client diversity helped the chain recover with clients still being able to propose blog and create attestations. So, which is a really huge win for client diversity. And I'm telling you, client diversity is really important. So that we know client diversity is important, and at the OP stack, we are really working very hard to achieve the client diversity, and we already have 6 clients, 2 in the consensus layer and the 4 in the execution layer. For consensus layer, we have OP Node, Magi, and for the execution layer, we have OP Geth, op-erigon, OP Reth, and oh shit, all right, OP Nethermind. So we have 6 clients. We're working really hard to achieve the client diversity for a safer chain. Let's go. Yeah, and now we're going to sync op-girly with op-erigon and op-node. Here's the plan. We're going to build and run the execution client, and which is op-erigon, and we are going to build and run the consensus client, and we are going to sync them with Engine API. It's quite simple. All right, requirements. You would need more than 16 gigabytes of RAM, more than 200 gigabytes of storage, because current op-girly is 150 gigabytes, so you would be fine for a few months. For Go, you would need this version of Go for this version of softwares. All right, let's go. I'm going to switch. Oh, I should. All right. All right. Guess. Can you read this? All right. All right, let's go. All right, so what I'm going to do is I'm going to first download the code and the database for op-erigon. But normally we don't download the database when we sync the chain. But we need this because op-erigon and op-geth does not support the pre-bedrock state transitions. At op-girly, we had a bedrock updates, which we don't want to support in the current version of op-erigon, so we just decided to build a database that contains all the pre-bedrock data. So, and then user can download it and use that on their own node. But in here, you can do it with this following commands, but I already did it because it's a few gigabytes, so I won't be able to make it. So what I'm going to do is, instead I'm going to set the directory to here, and we're good to go. And what you're going to do is we're going to build and start op-erigon. Okay, cd cd into the directory, make erigon, boom. Yeah, we're building erigon. Good, we built the erigon. And now we're going to execute this amazing client like this. So I set the data directory that I just set, HTTP port to this. This is Engine API port, and Taem is Optimism Girly. Let's go. All right, so my client is waiting for the consensus layer. it's up and running, I guess. Let's test it out. I'm going to open another terminal and send this curl command to check out what is the latest block of this client. I guess, wait a second, it's 0x3f, this one, so yeah, our client is, the block number is 4062780. Okay, so it's up and running. There we go. But still waiting for the consensus layer. Also, you all can use the link the OPR scan like this. Shout out to William again. So okay, so yeah, you can use this amazing blog explorer really easily if you sync the op-erigon. Yeah, it's the Optimism Mainnet, not the girly. You can see the transactions, beautiful. There you go. And again, and we are going to, what you're going to do is we're going to build and run the OP node. I already downloaded the code. So what I'm going to do is I already actually exported these variables. I am going to define the JWT token to the op-erigon's path. We need this JWT token to secure bridging. You know, if there is no authentication, then we can just hack the node. So we need this secure JWT secret file. And let's build OP node. Good, we're building OP node. Good, we built the OP node. All right, then what I'm going to do is I'm going to execute OP node like this, nice and easy, with set the engine API endpoints, enroll RPC, JW secret file, so it should work. No, it does not work. All right, MTL2 engine address. Okay, I did not set this, so I'm going to set this like this. It should work. There we go. So what you're doing is OP node is actually trying to simulate the path to sync the chain to the latest tip of this L2 from the node from the op-erigon client right here. So it's going to take some time to actually do the straight transition. So yeah, if you wait a bit with this, or like 5 to 10 minutes, it's going to sync the chain. I'll start to sync the chain, not sync the chain. And there are other methods that you can run the op-erigon or OP node. So for op-erigon, we are providing Docker image and the Helm charts so that you can use that on your infrastructure really easily. So you might want to try that too. Much easier integrations for your infrastructure. This is the end of my workshop. Thanks for coming and stay optimistic, y'all. Thank you.